Okay, we're now at video 7.8a, and we're going to talk about parallel lines. These are parallel lines right here. Parallel lines go on for infinity without ever touching each other. See that? We can figure out the graph of two equations are parallel. What does that mean? Well, the graph of two equations, if we have two equations, we graph them. See? We can tell if these two are parallel by the equations. Okay? Parallel lines in the same plane never intersect, and all vertical lines are parallel. See? These are all parallel to each other. They never intersect. Non-vertical lines, lines that have a slope to them, they're slanted, that are parallel will have the same slope but different y-intercepts. So look at these two lines. When we count their rise, we see they have a 2 and the run is a 3. So the rise and the run is the same, so the slope is 2/3 for both of them. But the pink one hits the y at 4, and the blue one hits the y at 1. That's their y-intercept. So they have the same slope, but different y-intercepts. So yes, we've proven they're parallel. See? So now we have these two equations, y equals 2x plus 5 and y equals 2x minus 3. These are equations that fit the graphed lines right here, the pink and blue lines. And the slope of each line is a 2, and they have different y-intercepts. The first equation, y equals 2x plus 5, has a y-intercept of 5. See? It hits right here on the 5. It tells us right here. And the second equation, it hits the y line at a negative 3. See? That's its y-intercept. So yeah, they're parallel. Now look at these two equations. We've got y equals negative 3x plus 4 and 6x plus 2y equals 10. Are these parallel? Well, this first one is in slope-intercept form, and this one is in standard form. We can solve the equations for y and then make sure they're in slope-intercept form. See? So we take the second one that's in standard form, and all we have to do is subtract 6x from each side. That'll create a zero pair here, and it'll eliminate it. And now we'll have 2y equals negative 6x plus 10. Now, we want to make sure that the negative 6x is up front here, in front of this y-intercept. That's the 10, okay? So now that we've got it in this form, it sort of looks like slope-intercept form, doesn't it? But we've got to simplify this and get y by itself on this side of the equation. So all we have to do is divide each term in this equation by this coefficient 2. It turns into our friend the invisible 1. That's identity property, isn't it? So we have just a y here. And we divide this by 2 and get a negative 3. We divide this by 2 and get a 5. Now they're both in slope-intercept form, and we can just look at them. See? They both have the same slope, a negative 3. And they have different y-intercepts. One's got a plus 4 and one's got a plus 5. So yes, same slope, different y-intercepts. They're parallel. All right? So once both equations are solved for y and written in slope-intercept form, we can just look at the equations and see if they're parallel or not. If we don't have equations, but we have a graph with ordered pairs, we can find each of their slopes by counting the rise and the run. This one has a negative 2 rise and a 4 for a run. This one has a negative 2 rise and a 4 for a run. See, they're sloping down, fall to the right, and it's negative. So they have a negative 2 over 4 as their slope, which simplifies to negative half for their slope. So they both have a negative half slope. That's the same. But the pink one's got a y-intercept of a 2, where it's hitting the y line, and the blue one's got a y-intercept of negative 1, where it's hitting the y line. So they've got the same slope, but different y-intercepts? Yes, they're parallel. So just make sure that any equations we use are in this form first. If it's in standard form, you want to use additive inverses and get it into slope-intercept form, okay? And just remember, same slope, but different y-intercept means parallel lines. Now we're going to talk about perpendicular lines next in 7.8b. And as always, in this playlist, if you want to go back to watch point-slope equation or slope-intercept equation videos, or our previous one of fitting equations to data, those links are going to be in here, okay? All right, on to perpendicular lines. They have 90-degree angles where they meet, don't they? Keep up the good work, and I'll see you. Bye.